Somewhere in Peru there is a wall that humiliates the best engineers of the 21st century. A wall that survived 3 catastrophic earthquakes while the Spanish churches beside it collapsed like sandcastles. A wall built with 200-ton stones, fitted together with a precision that exceeds the standards of the aerospace industry. And the most disturbing part, no one knows how it was built, not when, not by whom. For centuries they told us the Inca made this. Peasants with bronze chisels, stone hammers, no wheels, no writing, no cranes. But when you analyze the engineering, when you look at the real numbers, when you calculate what would actually be required to create this, the official story collapses, and something else emerges, something much older, much more advanced, and completely unexplainable. So let's do something different. Forget history for a moment, forget myths, forget legends. Let's talk only about engineering, numbers, physics, reality. The largest stone at Sacsayhuamán weighs 200 tons. To understand what that means, picture this: it's the weight of 130 family cars stacked at the same time. Now imagine this: you're in the year 2025. You have access to the world's best technology, the most powerful cranes, the most advanced tractors, a team of engineers from MIT and Stanford. Your mission: move that stone from a distant quarry to the top of a mountain at more than 12,000 feet altitude. How much would it cost? We consulted civil engineers specialized in megastructures. Their answer was simple: between $15 and $20 million just to move one stone. Sacsayhuamán has hundreds of stones this size. Do the math. But that's still not the impossible part. The impossible part comes now. Once you move the stone, you have to fit it. Not with cement, not with mortar, just stone, perfectly against stone. With a tolerance of 0.03 millimeters. For context, Boeing and Airbus engine components are manufactured with tolerances between 0.05 and 0.1 millimeters. Sacsayhuamán is more precise. With stone, without lasers, without computers, without steel tools. Do you start to see the problem? In 2019, a team of archaeologists used 3D laser scanning technology to analyze the joints at Sacsayhuamán. What they found left them speechless. The contact surfaces between the stones aren't flat. They're curved, perfect complementary curves, like two pieces of a puzzle designed by a mathematical genius. And here comes the disturbing part. There are no tool marks, none. Archaeologists searched with microscopes, with ultraviolet light, with advanced imaging systems. They found nothing. The surfaces are polished, as if the stone had been molded, not carved. When you cut stone today, even with industrial diamond saws, you always leave microscopic striations, tiny scars, invisible to the naked eye. But at Sacsayhuamán, there's nothing. No striations, no grooves, no cutting patterns. It's as if the stone had been melted, shaped like clay, and then solidified in place. Absurd? Maybe. But when you eliminate the impossible, whatever remains, however improbable, must contain some truth. In 2015, a Japanese engineer, an expert in industrial precision, visited Sacsayhuamán for a comparative study. His conclusion was published in a technical journal, and I quote, "Word for word, achieving this level of fit with current technology would require 3D laser scanning, parametric modeling software, and 5-axis CNC milling machines. Without these tools, I consider this construction technically inexplicable." Technically inexplicable, his words, not mine. But let's assume for a moment that the ancients somehow achieved microscopic precision. They still had to move the stones. The main quarry is over 12 miles away, but that's not the real problem. The real problem is the altitude. Sacsayhuamán sits at 12,000 feet above sea level. At that height, the oxygen drops to 65% of what you breathe at sea level. Your physical strength decreases, your heart works harder, your muscles fatigue faster, your brain slows down. Now imagine this: 1,500 people pulling ropes made of plant fiber, on a 15-degree slope, dragging a 200-ton stone at 12,000 feet, with electrical storms that appear without warning, with freezing nights dropping to 23 VF, no refrigerated food, no purified water, no medical care. Do you know what happens when you calculate the real physics of this scenario? The static friction of a 200-ton stone on irregular mountain terrain is brutal. You would need to apply a traction force of approximately 80 tons just to make the stone begin moving. 80 tons of force, perfectly coordinated, at the exact same instant. In 1998, a research team decided to test the traditional methods theory. They chose a stone weighing only 40 tons, not 200, not even 100, just 40. They gathered 200 volunteers, used modern ropes far stronger than anything available in antiquity, and after 8 exhausting hours, the stone had moved 36 feet. 36 feet, 8 hours, 2 people hospitalized. Now take that result, multiply the weight by 5, place it on irregular mountain terrain, and drag it for 12 miles, uphill, at 12,000 feet altitude. Do you start to see why the numbers simply don't add up? But here comes something almost nobody mentions, something far more disturbing. The stones at Sacsayhuamán aren't rectangular blocks. They're not neat cubes you can stack like Legos. They are organic shapes, twisting, flowing, irregular. Some have 12 angles, some have 20, some have 32. Each one is unique. Every contact surface is unique. Every fitting angle is unique. Do you understand what this implies? You can't prefabricate these stones. You can't cut them separately in a quarry and simply assemble them on site. Each stone has to be carved specifically to fit precisely against the stones that surround it. This isn't construction, this is sculpture, a three-dimensional puzzle of hundreds of pieces where every single piece weighs between 20 and 200 tons. Imagine the difficulty, imagine the calculations, imagine the centuries of trial and error that should exist before reaching this level of mastery, but they don't exist. The megalithic stones appear in history already perfected, already impossible, already beyond what we can replicate, even today. An experiment conducted in 1998 tried to do something simple, move a stone of just 40 tons, not 200, not 120, just 40. They used 200 volunteers, modern ropes, stronger than anything that existed in antiquity, perfect weather, controlled terrain, and the result? They managed to move the stone 36 feet in 8 hours, and 2 people were hospitalized in the process. 40 tons, 36 feet, 8 hours. Now multiply that by 5 and make it climb a mountain for 12 miles. Do you start to see why the numbers don't add up? But now comes something that almost nobody mentions, and it may be the most inexplicable part of all. The stones at Sacsayhuamán aren't rectangular blocks. They're not simple cubes you can stack like bricks. They're organic shapes, irregular, flowing, with 12, 20, sometimes 32 different angles. Each stone is unique. Each contact surface is unique. Each fitting angle is unique. Do you understand what this means? You can't prefabricate these stones. You can't cut them separately and then bring them together. Each stone must be carved specifically, precisely, to match the stones around it. It's a three-dimensional puzzle of hundreds of pieces, where each piece weighs between 20 and 200 tons. Now imagine the process. Carving an 80-ton stone with 32 contact surfaces. Each surface must align perfectly with the geometry of the neighboring stone, 1 centimeter at any angle, and the stone doesn't fit. You don't correct it. You don't adjust it. You throw it away and start again with another 80-ton stone. In 2020, a team of computational architects from Cambridge University attempted to simulate this process with artificial intelligence. Their algorithm worked non-stop for 3 weeks. 3 weeks just to calculate an optimal assembly sequence for 15 stones. That was the simulation, not the construction. Their conclusion: the combinatorial complexity of this fitting system exceeds any construction method known in antiquity. We found no viable model explaining how it was achieved without 3D modeling technology. Supposedly, 500 years ago. 500. Now let me show you something that truly breaks the narrative. May 12, 1650. An earthquake of estimated magnitude 7.2 strikes Cusco. The Spanish cathedral collapses. Colonial churches crumble. Thousands die beneath the rubble. Cusco is devastated, and Sacsayhuamán, intact. Not one stone displaced, not one joint opened, not one angle disturbed. In 1950, another devastating earthquake, magnitude 6.9. Cusco suffers massive destruction. Sacsayhuamán, intact. In 2007, another major earthquake, Sacsayhuamán, still intact. How is this possible? Structural engineers who have analyzed Sacsayhuamán have identified something extraordinary. The stones aren't fixed, they're designed to move. When a seismic wave arrives, the stones oscillate slightly, absorb the energy, and then return to their original position. It's the same principle we use today in Japan's most advanced skyscrapers, base seismic isolation. But there's more. The angles of the stones aren't random. They're tilted inward, between 3 and 15 degrees. This makes gravitational pressure push the stones toward the center of the structure, not outward. It's advanced seismic design, the type of design that didn't appear in the West until the 20th century. How did they know this? How did they anticipate earthquakes that would occur centuries after their supposed construction? Luck or knowledge they shouldn't have? All right, I hear the objection. It was the Inca. They had centuries to perfect the technique. Let's analyze that. Conventional archaeology says Sacsayhuamán was built in 2 phases. First, the Quilca culture, around the year 1100. Then the Inca completed the work between 1400 and 1500. But here's the problem. There's no evolution, no primitive version, no visible technological progression. In any other civilization in the world, you can see how technology evolves. Egypt's pyramids have smaller, simpler precedents. Greek temples evolved from wooden structures to stone. Roman aqueducts began as simple channels. There's always a progression. But at Sacsayhuamán, the megalithic structures appear complete, perfect, without trial, without error, without evolution. Quilca constructions are completely different. Small stones, irregular, with mortar. Nothing, absolutely nothing, in Quilca technology suggests they could make the leap to megalithic blocks. It's like going from a bicycle to a space rocket with no intermediate step. There's something else official archaeology can't explain. Pedro Cieza de León, Spanish chronicler, arrived in Peru in 1548, only 16 years after the conquest. He asked Inca nobles directly, "Who built this?" The answer is documented. I quote, "They say they don't know who did it, that it was already there when their ancestors arrived, and that they weren't men like them." The Inca themselves didn't know who built Sacsayhuamán. This isn't speculation, it's documented in 16th century Spanish sources. But Sacsayhuamán isn't alone. 200 miles away, Ollantaytambo, 50-ton stones transported from a quarry across a river and a mountain. With the same type of perfect joints, no tool marks, 250 miles away, Tiwanaku, stone blocks with cuts that look made with industrial saws, in a civilization that supposedly had no metal. And a few miles from Tiwanaku, Pumapunku, haze-shaped blocks, perfectly identical, as if they came from an industrial mold, with precision holes that archaeologists can't explain. What do all these sites have in common? The same type of megalithic masonry, the same impossible joints, the same absence of tool marks, the same lack of technological evolution, and the same testimonies from local inhabitants. It was already here when we arrived. This isn't coincidence, it's a pattern suggesting something conventional archaeology doesn't want to admit. There was someone before, someone with knowledge we don't understand, someone who left these structures and disappeared. Sacsayhuamán is a message written in stone, a message that says we were here, we knew things you still don't understand. If this was made by humans, they were the best engineers who have ever existed on this planet. They exceeded our industrial tolerances. They anticipated natural disasters. They moved mountains, literally. But if not, if this knowledge didn't come from natural evolution, then our history is incomplete, very incomplete, and perhaps the answers are waiting. Somewhere between these stones, waiting for us to ask the right questions,